Hi, today we are going to discuss the binomial theorem. Included in this video is a review of the summation and the product notation, the binomial coefficient, the Pascal's rule, and the binomial theorem itself. So kung ready na kayo, halina't matuto. So let's start with summation notation. Sa summation ng I equals m to n equals am plus am plus 1 plus a sub n plus 2 and so on and so forth up to a sub n. So the subscript iterates from m to n by 1. Here I is the summation index or a dummy variable, so it can be replaced by other variables. M is called the lower limit while n is called the upper limit. So the subscript m plus 1, m plus 2, and so on up to n, all the integers from m to n, where m is less than or equal to n, is called the index set. So the index set need not be a sequence of consecutive integers. In some form, we can define any set of real numbers as our index set. For instance, we can just say that I is a set. So simple properties of the summation, let n be a natural number, c is a real number, and ai's and bi's are sequences of numbers. Then summation of c from I equals 1 to n is simply nc. We can write it this way, summation of c is equal to c plus c, I equals 1 to n. So this is just like adding c n times. So these are n summands of c, or that's equal to n times c. Second property, if you have the summation of c times I equals 1 to n, you can factor out c in the summation. This is easy to see because CAI is c times A1 plus c times A2 and so on up to n, c times an. So we can just factor out c and we have the sum a1 plus a2 plus a3 and so on. And this sum is equal to the summation of ai. You can also distribute summation over sum. So we have summation of ai plus bi is equal to summation ng ai plus summation of bi. So that simply use the commutative property of addition. So you have on the first a1 plus b1 plus on the second a2 plus b2 and so on up to an plus bn. Since these are all additions and additions is associative, you can just neglect or remove the grouping symbols and then commute AIs and BIs. So you can collect AIs on one sum and BIs on the other. So the first sum is the summation of AI while the second sum is the summation of BIs. Of course, the lower limit may start with any integer m less than or equal to n. So it doesn't necessarily have to start with 1. Some simple example, let's evaluate the following summations. We have summation j equals negative 1 to 2 of quantity 5j quantity cube minus 2j. Summation of D squared, where D is an element of I. Here I is the set containing all positive divisors of 6. We can also have double summations, summations I from 1 to 2 of the summations from j equals 1 to 3 of 2ij squared. So let's look at the solution. For the first one, we just want to get the summation of the quantity 5j cubed minus to j. Here, j start from -1 to 3. If we apply the properties of the summation, then we can distribute summation over the difference. This is summation j equals -1 up to 3 of 5j cubed minus summation j equals -1 up to 2 of 2j. We can further apply properties of summation, so we can factor out the coefficients 5 on the first sum and the coefficient 2 on the second sum. So we have 5 times summation j equals -1 to 2 of j cubed minus 2 summation of j from -1 to 2. So now we evaluate the sum. So this is equal to 5 times. So all you need to do is to substitute j from -1 to 2, incrementing 1 every time. So we have -1 cube plus 0 cube plus 1 cube plus 2 cube. So that's from -1 to 2, incrementing 1 every time. Minus 2, this time summation of j. So -1 plus 0 plus 1 plus 2. Few correction. The 5 is included in the cube. So this should be 5 cube. This should be 5 cube. So this should be 125 times. So that's -1 plus 0 plus 1 plus 8. So the -1 and 1 will cancel. We have 8. Minus 2 times 2. Or that's just 996. Okay. All right. Now let's look at the second number. Summation of D squared. So again, your index set need not be a sequence of consecutive numbers. In this case, I is all positive divisors of 6. So what are the divisors of 6? So 1, 2, 3, and 6. So those are the positive divisors of 6. Anything that divides 6. So I contains 1, 2, 3, and 6. So we rewrite the summation as 1 squared plus 2 squared plus 3 squared plus 6 squared. So using our calculator, that's just 1 plus 4 plus 9 plus 36. So that gives us 50. Okay. Number 3 is a double summation. So we have the summation I from 1 to 2 and summation of j from 1 to 3 to ij squared. So what we can do here is we first evaluate the inner summation. So the inner summation is summation from j equals 1 to 3. We have I equals 1 to 2. So evaluating at j first. So using property of summation, we can factor out 2i. We can factor out I in the summation since in the inner summation, the index is j. So I is considered constant in terms of the index. So this is just summation I equals 1 to 2. We have 2i summation of j squared. J from 1 to 3. So now we can evaluate summation of j squared. So we have summation I equals 1 to 2, 2i quantity. So that starts from 1, so 1 squared plus 2 squared plus 3 squared. If you simplify that, that's 1 plus 4 plus 9, so that's 14. And then we multiply it by 2, so we have a summation of 28i. I is from 1 to 2. So this time, we can factor out 28 since it's constant. So we have 28 summation I equals 1 to 2 of I. So now we can evaluate summation of I, and that's equal to 1 plus 2. Or that's 3. 28 times 3, so that's equal to 84. Okay? So that's how we simplify summation. On the other hand, we can also use the same concept in product. So product is denoted by capital pi. The product of I from M to N is simply the product of all A sub M, A sub M plus 1, A sub M plus 2, and so on up to A N. So similar with summation, we just get all the AIs. I's increment by 1 from M to N. So here M is less than or equal to N. And instead of finding the sum, we're now finding the product of these AI. So again, I here is called the index, and the indices or the subscript M, M plus 1, M plus 2, up to N is called the index set. Again, index set need not be a sequence of consecutive numbers. It could be a predefined set of subscripts. M is called the lower limit, N is the upper limit. So if the lower limit and the upper limit is given, then you increment the lower limit by 1 until you reach the upper limit. For example, if you want to evaluate the product from I equals 2 to 5 of the quantity 2i minus 3, pi I equals 2 to 5 of 2i minus 3. So the product is, so we just increment I from 2 to 5. So that's 2 times 2 minus 3 times 2 times 3 minus 3 times 2 times 4 minus 3 times 2 times 5 minus 3. So really, it's the same as what we do in the summation, but this time, instead of adding the terms, we are now multiplying it. So every product, we increment I by 1. So we have the product of 1 times 3 times 5 times 7, 105. Actually, this is a very common operation in mathematics. This, if we have the product of I from 1 to n, what we really have is the definition of factorial. So n factorial is defined as the product of I coming from 1 up to n. So that's just n times n minus 1 and so on until you reach 3 times 2 times 1. Okay. Of course, 0 factorial is defined as 1. Okay. So let's define what we mean by a binomial coefficient. For any positive integer n and any integer k, such that k is between 0 to n, the binomial coefficients denoted by this one, n taken k. This is defined as n factorial over k factorial quantity n minus k factorial. This is defined as the combination formula. If you can see the symbol NCR in a scientific calculator, so that's what we mean by n taken k. Now, n taken k can be written as n times n minus 1 and so on up to 2 minus 1. Since k is between 0 to n, then of course, k is less than n. So, what you can do is you can factor k factorial in the numerator. So, if you factor this whole bunch of terms in the numerator, that's the same as k factorial. So, you're left with n minus 1 up to k plus 1 on the numerator, and on the denominator, n minus k factorial. So that's one way of simplifying n taken k formula. Now, you do that when k is larger than n minus k. But on the other hand, if n minus k is larger, so what you can do is instead of canceling just up to k, since now n minus k is bigger than k factorial, so what you can do is you can cancel n minus k factorial. So you can cancel up to this term. So if you cancel this term, you're left with n up to n minus k plus 1 on the numerator and k factorial on the denominator. So again, you can use this to simplify the binomial coefficient. If k is greater than n minus k, you can cancel k factorial. On the other hand, if n minus k is bigger than k, then you can cancel at most n minus k factorial. Again, since we're defining 0 factorial as to be equal to 1, so n taken 0 can be easily computed by formula, that's n factorial over 0 factorial times n minus 0 or n factorial. So that's equal to 1. Similarly, n taken n is equal to n factorial over n factorial times on the denominator times n minus n. So that's 0 factorial. So again, you evaluate 0 factorial as 1, so you have n factorial over n factorial is equal to 1. So n taken 0 and n taken n is equal to 1. So that means whenever you have this term here, that's just 1. Similar with this one. Okay? Now, what's the Pascal's rule? The Pascal's rule is this. Let n be a positive integer for any k from 1 to n. N taken k plus n taken k minus 1 is equal to n plus 1 taken k. So, if you have two binomial coefficients, you have the upper part of the binomial coefficients are the same. And then the lower part differ by 1. So, for example, let's say I have 7 taken 5 plus 7 taken 4. Add 1 on the upper portion, so that's 8. And then get the bigger lower part, so that's 8 taken 5. So this is a good way to simplify sum of binomial coefficients. So if you have n taken k plus n taken k minus 1, that's just the same as adding 1 on top and then getting the bigger lower part. Okay? So how do we prove this? This is really easy to show. We just have to start with the left hand side and then let's try to work our way on the right hand side. Okay, so we have on the left n taken k plus n taken k minus 1. Well, by definition, of course, this is n factorial over k factorial times n minus k factorial. On the other hand, n taken k minus 1 is equal to n factorial all over k minus 1 factorial, right? Times n minus quantity k minus 1 factorial, right? We can look at this too. We can see that n factorial is a common numerator, so we can take that out. So we have n factorial. Now, on the other hand, if we take a look at the denominator, right? Because this is k factorial, this is k minus 1 factorial. So at most, we can factor out k minus 1 factorial. Okay? How about n minus k and n minus quantity k minus 1? Of course, k minus 1 is smaller than k, right? So that means n minus k is smaller than n minus k minus 1. Mas malaki yung k, kaya yung n minus k mas maliit. Mas maliit yung, pag binawasan mo ng mas malaki yung n, liliit siya. Right? So, n minus k is smaller than n minus k minus 1. This is actually one value bigger. Parang, pag meron kang n equals 10, tapos k is 7, so 10 minus 7, tsaka 10 minus 6, right? So you have 3 here and 4 goes here. Mas maliit yung n minus k. Okay. So ano ibig sabihin? In terms of factorial, mas marami ng isang term to. Right? So that means I can factor this one out. N minus k factorial. So, ano natira sa atin? On the first fraction, we have 1 over, ang natira na lang dito yung k because we factor out k minus 1 factorial. Yung second fraction natin, makakancel natin yung n factorial, lalabas, tsaka yung k minus 1. Pero dito, tinanggal natin yung n minus k factorial. So, ang matitira yung dulong-dulo. 1 over n minus quantity k minus 1. So, n minus k plus 1. Right? That's n minus k plus 1. Again, ang matitira yung dulong-dulo na to. Pag kinancel mo yung, pag finactor out mo yung hanggang n minus k factorial. Parang, pag meron kang n equals 10, tsaka k equals 7, so anong meron ka sa denominator? So, meron kang isa, 3 factorial, sa kabila, 4 factorial. 10 minus 7, tsaka 10 minus 7 minus 1. 7 minus 1 is 6. So, 10 minus 6 is 4 factorial. So, pag finactor out mo yung 3 factorial, ang matitira yung 10 minus quantity 7 minus 1. So, yung n minus quantity k minus 1. Or, pag distribute mo yung negative, n minus k plus 1. Okay. So, we're almost done. So, n factorial over k minus 1 factorial, n minus k factorial. This one, we can combine as one fraction. So, that's k times n minus k plus 1. Right? So, this is n minus k plus 1 plus k. Okay. You can cancel k. So, you have n plus 1. So, you have n factorial times n plus 1 all over k minus 1 factorial n minus k factorial k times n minus k plus 1. If you look very carefully, saan equal tong term na to? N factorial times n plus 1. That's actually n plus 1 factorial. Right? On the other hand, you have k minus 1 factorial times k. So that gives us k factorial. N minus k factorial times the next number is n minus k plus 1. Right? Parang meron kang, ito yung 3 factorial, tapos yung susunod yung 4. So that's 3 factorial times 4. So that's 4 factorial, right? So that's n minus k plus 1 factorial. Now, we can look at this as n plus 1 quantity minus k. So you have n plus 1 factorial, k factorial, n plus 1 minus k. So this is exactly the same as n plus 1 taken k. So we're able to show equality. Right? Okay. So actually, Pascal's triangle, Pascal's rule gives rise to what we know as the Pascal triangle. In high school, we have this mnemonic device for us to remember how to get the binomial coefficients, right? So what we do is we create the Pascal triangle. So the Pascal triangle is actually the binomial coefficients when you expand a binomial. So, how do you create a Pascal triangle? You start with 1 at the top, and then on the next row, you get 1 in another one. So, the next succeeding rows, we were able to determine the value by adding the top rows. So, here, you just drop 1. And then here, you add the two coefficients, 1 plus 1. So, you get 2. And then here, you just drop 1. So, you just always bring down 1. So, the third row, the fourth row rather, so bring down 1. And then you add these two consecutive coefficients, 3, 3. And then you bring down 1. And then you do the same iterations every row. So once you have the row for n equals 3, you can generate the row for n equals 4. So just bring down 1 and then add the two consecutive coefficients. So we have 4, 6, 4, 1. Then we have 1, 5, 10, 10, 5, 1. For n equals 6, we have 1, 6, 15, 20, 15, 6, 1. But actually, even without the previous triangle or the previous row, you can get each you can get each value by this formula, n taken k. So, for example, let's look at this value, n equals 3. All this value can be computed using 3 taken k from 0 up to n. So, these values are actually equal to 3 taken 0, 3 taken 1, 3 taken 2, and 3 taken 4. So, you have 3 taken 0 is 1, 3 taken 3, this should be 3, is 1. So, 3 taken 1 is 3 factorial over 1 factorial times 3 minus 1, 2 factorial. So, that's, you cancel 2 factorial and you're left with 3. Here, we have 3 factorial over 2 factorial times 3 minus 2 is 1 factorial. So, you cancel 2 factorial. So, you have 3. So, 1, 3, 3, 1. So, every number here is determined by this formula. So, meaning on n equals 7, so you should have the formula 7 taken 0, 7 taken 1, 7 taken 2, 7 taken 3, 7 taken 4, 7 taken 5, 7 taken 6, and 7 taken 7. Now, of course, in computing the binomial coefficient, if you already have the sixth layer of the Pascal triangle, without actually computing for the value of 7 taken 4, you can do that by getting the sum of 20 and 15. And why is that true? Again, what is the value of 20 in terms of our binomial coefficient? This is on the row n equals 6 and on k equals 0, 1, 2, 3. So this is actually 6 taken 3, right? So if you imagine this value, this is 6 taken 3. On the other hand, 15 is 0, 1, 2, 3, 4. 6 taken 4. So what does Pascal's rule tells us? 6 taken 3 plus 6 taken 4 is equal to add 1 on top, 7, get the bigger one, 4. So this is actually 7 taken 4, which is this one. So that means the reason why that rule works simply by adding, right? We're just simply adding the two consecutive coefficients. Ina-add lang natin pero nakukuha natin yung nasa baba niya because of the Pascal's rule. Pag in-add mo yung dalawang coefficient, makukuha mo yung coefficient sa baba ng susunod na layer because of this formula. Because in terms of the binomial coefficient, this is 6 taken 3 and this is 6 taken 4. So 6 taken 3 plus 6 taken 4 gives you 7 taken 4. So that's on row 7 at k equals 4. So 0, 1, 2, 3, 4. Right? Okay, so doon galing yung rule natin ng pagbuo ng Pascal Triangle. All we need to do to get the next row is to add the two consecutive rows on the preceding row. Yung magkasunod na dalawang coefficient, pag inad mo, ibibigay niya yung coefficient on the next row. Yan. Okay. So, that gives us a way or a mnemonic device to determine the formula for a binomial expansion. So, ang rule, if you want to get the binomial expansion, of course, if you can't remember Pascal Triangle, what you will do is you need to evaluate this by hand. So, a plus b times a plus b. Of course, for a plus b to the 0, that's given, that's 1. A plus b to the 1 is simply a plus b. So, for any integer or any power greater than 1, you need to perform the multiplication. So, that gives us a squared plus ab plus ab plus b squared. Or that's a squared plus 2ab plus b squared. But upon expansion, we will see that the coefficients a, 2, and 1 actually appear on the row n equals 2 of the Pascal triangle. That's actually 1, 2, 1. On the other hand, the powers a squared, ab, b squared, so the powers of a and b decrease by 1 or increase by 1. So pag a, we start with the power 2, and then on the next term, the power of a reduced to 0. On the other hand, the power of b increased by 1. So you can imagine a squared b0 plus 2a1 b1 plus 1 a0 b2. So, yung pattern natin, yung a starts from 2, yung power ng a starts from 2, and then 1, and then 0. Sa baligtaran, yung power ng b starts from 0, and then 1, and then 2. And then we try to compute again a plus b cubed, pero syempre that's just a plus b squared a plus b. So if you perform the long multiplication, you will have a squared plus 2ab plus b squared times a plus b. So you multiply this one, you distribute a, so you have a cubed plus 2a squared b plus ab squared. Now, when you distribute b, you have a squared b plus 2ab squared plus b cubed. So you'll have this one, a cubed, 2a squared b, 3 rather, 3a b squared b cubed. So we can observe the same pattern, right? So the powers of a starts from 3 and then reduced by 1. So 3, 2, 1, 0. There's no a here. On the other hand, the powers of b starts from 0. So you can imagine there's a b0 here, and then b to the 1, and then b to the 2, and then b to the 3. Now, the coefficients, on the other hand, are 1, 3, 3, 1, and we observe that these appear as the row n equals 3 of the Pascal triangle. So, in general, we hypothesize that if you have a plus b to the n, then the coefficients will be the row n of the Pascal triangle. So for example, on a plus b to the 5, so the coefficients for n equals 5 is 1, 5, 5, 10, 5, 1, 1, 5, 10, 10, 5, 1. So you have the coefficients 1, 5, 10, 10, 5, 1. And then you add the powers a, I, B, J, right? Where I starts from 5 and then reduce by 1 every term. And then B starts from 0 and then increase by 1 on each term. So you start with A5, B0, A4, B1, A3, B2, A squared, B cubed, A to the 1, B to the 4, A to the 0, B to the 5. Okay? And then we try to generalize that. So by our previous observation, every coefficients or every row on our Pascal triangle is the same as our binomial coefficients n taken k, where n taken k is defined as the binomial coefficient n factorial over k factorial n minus k factorial. So, meaning, we can now generalize the binomial expansion even without creating the Pascal triangle. Pwede na nating makompute yung binomial expansion kahit hindi natin alam yung Pascal triangle o kahit hindi natin buuin yung Pascal triangle. Well, what's the problem with our Pascal triangle? The problem with our Pascal triangle is for us to create the nth row, kailangan natin yung previous row. So meaning, kung ang i-compute mo ay a plus b to the 10, for example, a plus b to the 10, kailangan i-create mo muna yung Pascal triangle mo na ang size ay hanggang 10. Kailangan mo yung n equals 10. Pero bago mo ma-create yung n equals 10, kailangan mo yung 9, kailangan mo yung 8, 7, 6, 5, and so on. So, the larger the value of n is for the binomial expansion, the bigger the Pascal triangles becomes. So, the harder it is for us to create the Pascal triangle. Siyempre, imagine kung meron tayong a plus b to the 100. So, it's very tedious for us to create a triangle of size 100. Ano namang bumuo tayo ng sobrang laking triangle. Imagine how tedious that would be. So, the advantage of us relating the triangle in terms of the binomial coefficient reduces drastically the operations involved. So, hindi natin kailangan mag-create ng sobrang laking triangle para i-compute yung binomial expansion. So, in general, we have the formula a plus b to the n is equal to, so yung mga binomial coefficients that creates the row for our Pascal triangle. So that's n taken 0. So start with 0. So n taken 0, n taken 1, n taken 2, up to n taken n. So there are n plus 1 terms in a binomial expansion, right? Next, the aibj term starts from a to the n. So the first term is a to the n. And b to the 0. So we no longer need to write b to the 0. The next term is we reduce the coefficient or the power of a by 1 and we increase the power of b by 1. So palitan lang sila. Habang nababawasan yung exponent ni a, yung nabawas mo kay a, dadagdag mo lang kay b. So minus 1 sa n plus 1 sa b. So, always, ang sum ng exponent laging n. Yan. Yung susunod, n minus 2 na. So, kung ano yung minus mo sa A, idadagdag mo lang sa B. So, n minus 2 sa A, 2 sa B. So, in general, n minus k yung A, k yung sa B. Right? So, ang formula pala nung ano natin, nung factor AB natin, A to the n minus k, B to the k. So, ano na yung naka-minus sa A, yun na yung naka-raise sa k. And so on, hanggang ma-reach mo yung n minus n for A, which is 0. So, A to the 0, B to the n. So, that's our formula for binomial expansion. So, in general, we write that as the binomial theorem. So, let AB be two real numbers for any exponent n. From the set of natural numbers, we have A plus B quantity to the n equals. So, we just put it in summation notation for a more compact form. So, summation k equals 0 to n of n taken k, a to the n minus k, b to the k. So, ito yung general formula. Yan. So, for every k starts from 0. So, n taken 0, a to the n, b to the 0. Yung sunod, n taken 1, a to the n minus 1, b to the 1. Yung susunod, n taken 2, a to the n minus 2, b to the 2. So, this gives us a more compact notation to write this whole formula. So, this whole formula here is equal to the summation k starts from 0 to n of n taken k, a to the n minus k, b to the k. So let's try to prove that indeed the formula holds or the formula is true. Of course, we just hypothesize this using the pattern. Hindi naman natin in-evaluate talaga yung a plus b to the n, di ba? So every time we have a formula in number theory, we need to prove that that formula is true. So how do we do that? This is a very simple use of induction. Usual naman sa number theory, when we have a formula in terms of n, induction is a very formidable device for us to prove that particular property for the set of integers. So, let's say that this statement, let's call it P of n. The statement that says a plus b to the n is equal to summation of n taken k, a to the n minus k, b to the k running from 0 to n. Tawagin natin siyang P of n. So, we want to show that P of n is true for all integers n. So, paano natin gagawin yan? So, we just follow the rules of induction. First, we need a basis for induction. Tama? So, we proceed by induction. Okay? So, we have to start with a basis, of course, as always. Again, remember, yung induction natin may tatlong step. We need the basis, we need the hypothesis, and we need to provide the proof of induction so that we can conclude that P of n is true for all the starting value of n. So here, the starting value of n is 1. So let's prove that n equals 1 holds for P. So for n equals 1, the left-hand side is equal to a plus b to the 1. And that's just equal to a plus b. On the other hand, the right-hand side is equal to, so since this is a summation, so this is summation from k equals 0 to 1 of a to the 1 minus k, b to the k. Okay, so we start with k equals 0. So at k equals 0, that's just a to the 1, b to the 0. Plus, at k equals 1, so that's a to the 0, b to the 1. Or that's simply a plus b. And indeed, the left-hand side is equal to the right-hand side. Therefore, p of 1 is true. So we have our basis. Okay. So now we can assume that this holds for any integer n. So let's have a proof of induction. hypothesis first. So we hypothesize that P of n is true for some integer n. I didn't use K. Usually, ginagamit natin P of K, di ba? Kasi malilito tayo dun sa subscript na K. Madodoble yung ibig sabihin ng K eh. So, we cannot abuse K in this particular scenario. So, let's stick with N. So, since ang ina-assume natin true ay P of N, ano kailangan natin pakita? Kailangan natin pakita na ang P of N plus 1 is true. So, that's the proof of induction. So we need to show, right? So we need to show that P of n plus 1 is true. Okay. So hindi naman kailangan laging K gagamitin mo. Kahit anong variable, kahit M gamitin natin, kahit N, kahit S, basta pag inassume mo na P of n is true, ang ipapakita mo, P of n plus 1 is true. Yan. I just avoid K again to reiterate kasi malilito ka sa subscript na K, pagka K din ang ginamit mong P of K. Imagine, pagka P of K yan, summation K equals 0 to K. That's ambiguous. Kaya I avoid K. So we want to show that if P of n is true, then P of n plus 1 is also true. Right? So, what's P of n plus 1? Ibig sabihin, yung formula na to, palitan mo lang ng n plus 1, yung lahat ng n. So, ang gusto mong ipakita, ang a plus b to the n plus 1 ay equal sa summation k equals 0 to the n plus 1 ng n plus 1 taken k, a to the n plus 1 minus k, b to the k. So, gusto mong pakita na totoo yan. So, let's start with the left-hand side and then let's show that the right-hand side is indeed the same as this one. Okay? So, start tayo sa a plus b to the n plus 1. Okay. Now, when you're proving equality, avoid the style that you do in high school where you write them side by side. One is, it's too tedious to write the right-hand side all over again. Di ba? Masyadong matrabaho, isusulat ko lagi, summation. Yun yung style ng some of you eh. Ginagawa nung iba sa inyo, sulat ng left-hand side dito, equal sa right-hand side. Tapos isi-simplify ito, equal sa right-hand side pa rin. Naka-right lang na naka-right yung right-hand side. So, tedious yun, di ba? Sayang yung effort na isulat mo pa ulit. That's one. The second, and a more important to note, is that pagka kasi sinusulat mo yung dalawa na equal, you're already claiming them to be equal. Tama? Kiniklaim mo na equal sila. So, ano pang pinuprove mo kung kinlaim mo na equal? So, pag sinabi mo na ang A equals sa B, so sinabi mo na A equals B. Kahit palitan mo ito ng C, so sinabi mo na C equals B. B equals B. Tama? And that's a wrong way to prove that. Maybe, kung lalagyan mo muna ng question mark, ibig sabihin, tinatanong mo pa muna kung equal sila. So, that's one way to go about it. But again, to be mathematically correct ha, kasi mathematically speaking, kung ini-equate mo na sila agad, ibig sabihin sinasabi mo na equal sila. So there's no point yung pinuprove mo. Siguro maling technique lang or siguro yung natutunan natin nung high school, incomplete yung meaning ng statement. Parang nakasanayan na lang natin yung teacher nating nakikita na ini-equate lagi ng ini-equate. Which is wrong when you're proving equality. When you're proving equality, you cannot state yung pinuprove mo from the beginning. So, dapat magsimula ka sa isang side lang, papakita mo yung another side. So, yun nga, to fix that, pwede mo lagyan question mark muna. And then at the end, kung equal na talaga, tsaka mo i-check. So that we have an understanding, okay, sa simula, tinatanong mo pa lang, ay, okay, equal pala. Equal ba sila? Yun yung tinatanong mo. Or, you can use a logical symbol. Paano mo sasabihin yung logical symbol? You're claiming that this is true if and only if the next statement is true. Kumbaga, pinapakita mo yung equality ito, magiging true lang yan if and only if you change the left-hand side with an equivalent statement. So, logical operator na kailangan mo if and only if. So this is true if this is true. Kailangan mo if and only if, hindi pwedeng then. Bakit? Kasi kailangan mong bumalik eh. So pag then lang kasi, from left hand side, pupunta ka sa right hand side. From right hand side, hindi ka makakabalik sa left hand side kasi then lang eh. So kailangan if and only if. So this is true if and only if the next statement is true. If and only if the next statement is true until the time na meron kang dalawang statement dito na apple equals apple. Di ba? Pag nakita mo na yung apple equals apple, then this is obviously true because of the biconditional statement that makes the very first statement to be true. So, ganun yung pag-prove dapat. Okay? So, again, I don't want to see you guys proving equality by stating the equality that you want to show right away to be true. Parang kinlay mo na equal sila eh. Ang isa pang nangyayari, may mga instances na pag sinusulat mong equal, sometimes nakakita ka rito ng 2 apple equals 2 apple. Ginagawa mo, kinakancel mo yung terms na nasa both side of equality. Well, you cannot do that. Why? You can only cancel 2 terms on either side of the equality if they are indeed equal. Kung equal na talaga sila, tsaka ka lang pwede mag-cancel. Pero kung hindi sila equal, hindi mo pwedeng i-cancel or hindi mo pwedeng i-operate yung mga terms from left at saka yung mga terms sa right. Hindi sila pwedeng maghalo. May wall between them dapat. Hindi pwedeng maglipat-lipat. Hindi pwedeng mag-operate together. Why? Kasi ginagawa mo lang yung operations na nagka-cancel ka, nagta-transpose ka. Diba? Nakakita ka dyan ng +1. Ang ginawa, nilipat doon yung -1. Mali yun. Because those are properties of equality. Bago mo magawa yung mga properties na yun, ina-assume mo na equal yung dalawa. So, ibig sabihin, incoherent yung ginagawa mo doon sa gusto mong patunayan. Bakit? Gusto mo nga sabihin, gusto mong patunayan na equal sila. Tapos, gumamit ka ng operation na nakadepende sa pagiging equal nila. So, yun yung mali doon. Kasi, pinoprove mo yung equality nila pero ginagamit mo na rin yung property nila as equal sila. Nakukuha ba yung logic? So logically mali. Na ginagamit mo yung mga properties ng equality kung ang pinoprove mo yung equality ng dalawa. Hindi pa nga sila equal ini-establish mo pa lang. Kung na-establish mo na equal, then tsaka mo pa lang pwedeng i-cancel. So hindi pwede yung meron ka ditong 2 something, di ba? Meron kang 2x equals 2y. Kinancel mo yung 2. So, sinabi mo x equals y. So, left hand side equals right hand side. Mali po. Mali yan. Okay? That is very wrong. Parang ganito yung ginawa mo eh. Gusto mong ipakita na 2 times 1 is equal to 2 times 0. So, cancel mo yung 2. Natira 1 equals 0. Totoo ba 1 equals 0? So, hindi. Kasi sa simula pa lang, ini-establish mo na yung equality nila. Kaya ka nalito na pagdating sa dulo, 1 equals 0. So that's what I'm trying to say here. So you need to be logically sound pag pinuprove mo ang equality. Yan. So either you use biconditional symbol para sa logic or mas matipid, huwag mo na isulat yung right hand side. Start ka lang sa left hand side and then from the left hand side, try to achieve the right hand side. So let's start properly with left hand side without writing the right hand side. Gusto natin puntahan yung right hand side eh. So kalimutan mo muna yung right hand side. From time to time, you can check the right hand side para lang malaman kung papunta ka ba doon sa part na yon. Pero wag mo isusulat completely doon sa tabi ni left hand side. Kasi nga gusto pa lang nating i-prove yung equality. So hindi pa sila talaga equal. So ano yung left hand side? A plus B to the n plus 1. Yan yung left hand side. So, let's start with this and what we know. This is what we know about a plus b to the n plus 1. This is a plus b to the n times a plus b. Right? That's what we know. Okay. We can, by DPMA, distributive property of multiplication, distribute a plus b to the n. So, this is the same as a plus b to the n times a plus A plus B to the N times B. So now, we go to our hypothesis. Ano ba sinasabi ng hypothesis? Ina-assume natin that P of N is true. Ano yung P of N? Ito yung P of N. So we assume that to be true. So now, we can use that because it's part of the hypothesis. So as hypothesized, A plus B to the N is equal to summation ng K equals 0 to N taken K, right? A to the N minus K, B to the K. So everything times A. The same quantity, that summation, K equals 0 up to N, taken K, A to the N minus K, B to the K, this time multiply it to B. Right? Okay. So now, we need to simplify. First, we need to expand the summation so that we can multiply A, and then we can simplify whatever we can in the expression. Okay? So let's expand. So if we expand this one, we have N taken 0 times A to the N plus N taken 1, A to the N minus 1, B to the 1 plus N taken 2, A to the N minus 2, B to the 2, and so on. We cannot write every term. Siyempre, variable yung N natin. Indeterminate. Arbitrary. Okay. So, but you know the pattern. So, yan yung pattern. Hanggang makarating ka dun sa dulo. Ano yung dulo? N times N minus, taken N minus 1, A to the 1, B to the N minus 1. Right? 1 na lang yung sa A kasi N minus, quantity N minus 1. So, 1 na lang matitira. B to the N minus 1. Plus, yung pinaka-last na term, N taken N, B to the N. So, lahat yan, i-multiply mo lang ng A. Right? Plus, the same thing, so that same quantity times B. Okay. So, let me expand that. So, times A. So, I have N taken 0, A to the N plus 1, plus N taken 1, A to the N. If we multiply everything by A, the power of A will increase by 1. B2 plus, and so on. Up to the end. N taken N, A, B to the N. Right? Wait. This should be 1. Right? B to the 0, B to the 1, B to the 2. Alright. So, this is, now this time, multiply it by B. So, N taken 0, A to the N times B. So, itatapat ko siya dito. Kasi alam ko na common term sila. And so on. So, lahat yan, multiply mo by B. So, ito magiging B squared, B cubed. Ito magiging B to the N. So, this is N taken N minus 1, A to the 1, B to the N. Plus, yung last term, times mo by B. So, that's N taken N, B to the N plus 1. Okay. So, adding the common terms, we have N taken 0, A to the N plus 1, plus, so this is quantity, N taken 1, plus N taken 0. Common factor, N, A to the N times B. So, lahat ng magkakatapat, magkakaroon ka ng yung susunod, N taken 2. Tama, yung susunod na term dyan is N taken 2, plus, yung susunod na term dito, N taken 1. Right? Times the quantity A to the N minus 1, B squared. And so on. Hanggang dun sa dulo. So, yung last na may sum is yung N taken N plus N taken N minus 1 times A to the Bn. And then the last term, siksik na lang natin dito, N taken N, B to the N plus 1. Right? So, lahat may katapat except yung first saka yung last. So, yung mga magkakamuka, ilagay natin sa isang quantity, finactor out natin yung A to the N minus K, B to the K. We can further simplify. So I can rewrite this as n taken 0 to the a n plus 1 plus, so this is n plus 1 taken 1, a to the n b 1 plus, this is n plus 1 taken 2, right? A to the n minus 1 b 2 and so on. This last term here is n plus 1 and then the bigger one is n. So the bigger bottom, n and n minus 1. So a to the bn plus n taken n b to the n plus 1. Right? So doon natin nagamit yung Pascal's rule. Kung titingnan nyo, yan yung dalawang, remember, we're on the nth power, di ba? Niraise natin sa nth power. Pero, pag in-add mo yung dalawang binomial coefficient, yung dalawang magkasunod, nagiging coefficient siya ng susunod na power ng n plus 1. Right? So, dun galing yung, parang ito na yung general Pascal Triangle natin. Yan. Gamit yung Pascal rule. So, ganun yun, nabubuo mo yung mga coefficients nung pang n plus 1 gamit yung coefficients nung pang n. Kasi itong mga to, galing to sa n eh. Yung mga coefficients niya galing sa n. Okay. So, kung makikita natin, this is already correct in our formula, di ba? N plus 1 taken 1, n plus 1 taken 2, n plus 1 taken 3, and so on, n plus 1 taken n. Alin na lang ang problema? Ito na lang. Dapat n plus 1 din siya. Right? Pero, you take a look at n taken 0. Ano ulit ang value ng n taken 0? Ang n taken 0 is simply 1. Ang n taken n is simply 1. Tama? Yun yung rule natin eh. Ibig sabihin, kahit ano ang nasa taas, basta 0 yung baba, 1 yun. So we can replace this by n plus 1 taken 0 and they are still equal. Tama? Kahit ano yung nasa top, basta yung nasa baba 0, yung n taken 0, 1 yun. So yung n plus 1 taken 0, 1 pa din. Yung 1,000 taken 0, 1 pa din. Yung 1,001 taken 0, 1 pa din. So equal pa din yan. Tama? So I rewrite the n taken 0 as n plus 1 taken 0. Parang tinweak natin ng konti. Yan. So this time, yung coefficients ni a to the n plus 1, nag-agree na. Di ba? So this is n plus 1 taken 1. Now take a look at a to the n. That's actually equal to a to the n plus 1 minus 1. Ha? Tapos yung b to the 1. So nag-agree na kung ano yung k, yun yung naka-minus dun sa n niya. So since ang top natin n plus 1, yung exponent ng a, n plus 1 minus 1, minus k. So yung b ganun din, b to the k. So pagka ang k natin 2 na, n plus 1 taken 2, so yung n minus 1 can be written as well as a to the n plus 1 minus 2. Di ba? That's n minus 1. Tapos b2. So nag-a-agree na din. N plus 1 taken 2, a to the, kung ano yung nasa taas, n plus 1 minus 2, minus k. Kung ano itong nasa baba, so taas minus baba, taas minus baba, tapos ito yung baba. Right? So, nag-a-agree na yung formula natin. Hanggang dito sa part na to, n plus 1 taken n, a to the, yung a to the 1, pwede mo siyang isulat as n plus 1 taas minus n, baba. Tapos b to the n. Plus yung dulo, again, n taken n is simply 1. Pero, that's the same as n plus 1 taken n plus 1. Kasi sabi ng rule, basta equal yung taas at baba, equal sa 1 yung n taken n. Times b to the n plus 1. Right? This is summation. Tama? K equals 0 to n plus 1 ng n plus 1 taken k, a to the n plus 1 minus k, b to the k. But this is exactly the right-hand side. Tama? Ano ibig sabihin? Therefore, p of n plus 1 is true. This is true. Napakita natin na yung left hand side equals sa right hand side. So, we complete the proof of induction. Whenever P of n is true, it follows that P of n plus 1 is true. Then, by induction, P of n must be true for all integer n. So, yun. Na-prove natin by induction. Yan. That's why it's very important na marunong kayong mag-prove ng induction, especially in number theory, because most of the properties in number theory will be shown using induction. That's a very simple application of induction actually. Let's have an example of how we can utilize the binomial theorem. This is an easy example. Expand 2x minus y to the 8. Now, if you want to create the Pascal triangle, go ahead and create the Pascal triangle. But of course, if you can remember the binomial theorem instead, that would be better. Diba? Okay, so let's try. 2x minus y to the 8 is equal to, so let us write the binomial in the sum form. Bakit? Kasi yung formula natin nakasum. Yan. Pero again, ang minus naman ay ano lang naman, di ba? Additive inverse. So, plus the negative lang naman ng second term. Okay. So, suppose wala tayo ng Pascal triangle. So, by formula, this is 8 taken 0, 2x to the 8 plus 8 taken 1, 2x to the 7, negative y to the 1 plus 8 taken 2, right? 2x to the 6, bawas ng isa, dagdag ng isa. Basta check nyo, ang exponent laging equal sa 8. Sunod-sunod yan. Plus, 8 taken 3, 2x to the bawas ng isa, negative y, dagdag ng isa. Plus, 8 taken 4, 2x, what's that? 4. Negative y to the 4 plus 8 taken 5. Minsan, pag masyado na madami sinusulat mo, mawala ka na sa pattern. Tatandaan mo lang, taas minus baba. 8 minus 5. Yun yung una. Taas minus baba. 3. Tapos baba. 5. Plus 8 taken 6. O de, 2x. Taas minus baba. 2. Negative y. Baba. So, 6. Plus, yung sunod, 8 taken 7. So, 8 minus 7, 2x to the 1. Tapos yung negative y to the 7. Plus, 8 taken 8. So, 0 na yung 2x. So, negative y na lang to the 8. Okay? Now, if you already have the values for the Pascal triangle, you can go ahead and substitute the values for 8 taken 0, 8 taken 1, 8 taken 2, and so on. Anyway, pwede mo namang i-calculate na lang. So, if we simplify the coefficients, 8 taken 0 times 2 to the 8, so that gives us 256. So, that's 256 x to the 8. The next term, we have the negative y factor raised to 1. So that will give us a negative coefficient. So 8 taken 1 is 8 times 2 to the 7. So that gives us 1024 x to the 7, y to the 1. Plus, so 8 taken 2 times 2 to the 6, that's 1792 x to the 6, y squared. Now, the next term will involve negative y cubed. So, that gives us a negative coefficient. 8 taken 3, right, times, this time 2 to the 5. So, 8 taken 3, 2 to the 5 is 1792 as well. So, 1792 x to the 5, y to the 3, plus the next term is 1120 x to the 4, y to the 4, minus, so expect that the terms will be alternating in signs. Kasi the factor negative y is being raised to 1, 2, 3, 4. So the negative sign contributes an alternating signs for coefficient. So we have, for the next term, 448 x cubed y to the 5 plus 112 x squared y to the 6 minus 8 taken 7. So that's just 8 times 2, 16 x y to the 7 plus 8 taken 8 is 1, negative 1 to the 8. That gives us plus 1. So y to the 8. Yeah. Okay. So for the coefficients, you can just use a scientific calculator and plug in the values as easy as that. Let's have another example. Consider the power x squared minus 2y cubed raised to 100. This will give us an idea how binomial theorem actually works without expanding the binomial expansion. Give the fourth term of the expansion according to the binomial theorem and find the term which involves the factor y to the 45 and the term which contain the factor x to the 10. Okay, so how do we find the fourth term without actually expanding? We need to remember the binomial theorem. The binomial expansion of x minus 2y cubed raised to 100 is the summation k from 0 to 100. 100 taken k, first term is x squared raised to 100 minus k, and then negative 2y cubed raised to k. So that's the expansion. All right. But what we want is the fourth term. So how do we determine the nth position in our expansion? The nth position corresponds actually to k equals n minus 1, right? If we want the nth position, that actually corresponds to k equals n minus 1. Because k starts with 0. So the first position is k equals 0. The second position is k equals 1. So second position, 2 minus 1. The third position is k equals 2. So third position, 3 minus 1. So the formula is for the nth position, we need k equals n minus 1. Okay? So that's clear. Since we want the fourth term, that corresponds to k equals 3. So for the first question, we want the fourth position. But the fourth position is given by k equals 3. So the fourth term is equal to k equals 3. So that's 100 taken 3 x squared raised to 100 minus 3. So that's 97. Negative 2y cubed 3. Okay? And simplify. So, using calculator, if you compute 100 taken 3 times negative 2 to the 3, so that gives you negative 1293 600 x to the 2 times 97, so that gives us 194. Y 3 times 3, that gives us 9. Okay? Now, the next question is we want to find the term which involve the factor y to the 45. So, how do we determine k? If we want the factor y to the 45, that means that will come from the term negative 2 to the y cubed raised to k. So, we can rewrite y to the 45 as y 3 raised to 15. So that means this is k equals 15. Right? So what we want is actually the 16th term. The term with the y45 is determined by k equals 15, which is the k plus 1 term, the 16th term. Okay, so the 16th term is given by 100 taken 15 x squared raised to 100 minus 15, so that gives us 85, times negative 2y cubed raised to 15. Again, using a calculator, you get 100 taken 15 times negative 2 raised to 15. Let me write it first. That's 100 taken 15 times 2 to the 15. Let me write the negative on the left side. And then that gives us x to the 170, y to the 45. If you use a calculator, this value here is approximately equal to 8.3 times 10 to the 21. Negative. So that's x to the 170, y to the 45. Okay? Now, what if we want x to the 10? We want to determine the term containing the variable x to the 10. Same technique. If you want x to the 10, that means we need to raise x squared to 5. But according to our formula, we get the coefficient x to the something by the formula x squared to the 100 minus k. So we want 100 minus k to be 5. Right? This means we want 100 minus k to be 5. So that means k equals 95. So what we're actually trying to determine is the 96th term. Again, that term is always determined by n minus 1. K equals n minus 1. So the the 96th term will give us a value of k equals 96 minus 1 or 95. Okay? So the term that we want, which is the again the 96th term, is given by the formula 100 taken 95. Okay, magpapalito baka 96 mailagay nyo. K is 95. Yeah. This is always equal to k plus 1. The position is equal to k plus 1. So 100 taken 95, x squared, 100 minus 95, so that gives us 5. Negative 2y cubed raised to 95. Okay? So, this will again give us a negative value. So, negative 100 taken 95, 2 to the 95, x to the 10, y to the 3 times 95, 285. Alright. Now, if you use a calculator, this is approximately equal to 2.98 times 10 to the 36. So that's x to the 10, y to the 285. Okay? So that's how you use binomial theorem without actually computing for the binomial expansion. We were able to determine specific terms of the expansion using the binomial theorem. So again, that is given by summation n taken k, a to the n minus k, b to the k running from 0 to n. For small values of n, you can go ahead and use Pascal Triangle. Anyway, the proof of binomial theorem is just based on the Pascal's rule, which create the Pascal Triangle. So for a small value of n, kamukha ng mga nakukuha natin ng high school, yes, so can use Pascal Triangle. But for very large values of n, it will be really inconvenient and tedious to create a very large Pascal Triangle. So for that, we have the binomial Theorem.